Начата запись встречи.
Hello, my dear students. That is lecture class about introduction of aerospace engineering, introduction to the major as it's written in your curriculum. And we are continue to talk about manufacturing. Previous time we have stopped at sheet metal stamping. I remind you dreadful picture that we haven't finished yet, barely started. We talking about so-called general sequence of transformation in mechanical engineering, no, in industry of mechanical engineering type. But all the possible variants of transformation we have divided onto 5 groups. No, not we, but it's proposed to do it like this in our textbooks. Do remember each time when we're talking about classifications that all classifications, whatever science, whatever features we're using to categorize objects, processes whatsoever, it's all conditionary. It's all may be represented in different ways, and all these classifications they are mostly necessary to systemize, to arrange somehow our knowledge in order it would be more ordered, more useful for using, let's say. However weird it sound for the first period, but all these classifications should help us and should help us to find, to notice similarity and to search for new decisions, let's say. Now, let's continue. Where we are, remind you, in transformations of shape. What does it mean, transformation of shape? You, of course, remember, it means that we do not separate anything, do not cut, and do not add anything. We just changing the volume that we have. And among of these big groups, we started with casting. Next, we talked about so-called primary deformation methods. Because why they are called primary? Because they are started immediately after the very first casting happened after the metallurgical oven, metallurgical furnace. And primary deformations, as you remember, of course, are rolling, extrusion, wire dragging, in order to have same product convenient to work with next. And among these semi products, we have sheets, profiles, and pipes. Those sheets, profiles, and pipes, next, they became the workpieces for another group of transformation. This another group is at the bottom, sheet metal stamping. But as only we open a book, we have already did it, the book of Michael Groover, that should help us much. Do pay attention, here is sheet metal working, it's called sheet metal working chapter. And what do we see in the chapter, in content of this chapter immediately? We see that it begins with cutting operations. What do I mean to remind you? That this sheet metal stamping, it's also hidden, some portion of it, it's also hidden in transformation of volume. But we right now will talk only about deforming operations of sheet metal stamping, and traditionally it started with bending, deep drawing. Do pay attention, it's already second time when we see this word. No, besides that it means to draw something by hand to create some picture according to engineering standards, it's already appeared that it's process of creating of wires with the name wire drawing or wire dragging maybe. And it's so-called deep drawing. Typically, it's called in English literature deep drawing, maybe to help to, to distinguish from another processes. And here it's called like other metal forming operations or the miscellaneous operations. We will need to see some the most typical for aircraft manufacturing operations in order to familiarize with them. Let's continue. Do pay attention that what is understood as sheet. Sheet. No, here it's proposed that it's from 0.6 to the 6 millimeters, like this. If it's thicker, it's already called plate. If it's thicker than 50 millimeters, let's, oh, disappeared. Yes, here. Да. If it's thicker than 6 millimeter, it's plate, and 50, it's already called slab, and next it will be bloom. But thicknesses right now will not say, in order not to mislead you. Well, and once again, what does it mean sheet? One size is significantly less than to another overall sizes. And the same we might say about extruded profile. One of sizes, in cross-section thicknesses of thin walls, they are much, much, much less than longitudinal size. And thin pipes, the same story. So they are all considered like sheet metal workpieces. First, before we talk about sheet metal different operations, let's recollect what did I say about equipment, tools or instrument, and tooling. What is equipment? Typically for sheet metal stamping, used equipment press. Not hammer this time, only presses. Presses may be once again of two different types. The most popular is mechanical. Here is represented picture with mechanical presses. Typical press, maybe you have already seen such things. Easy to recognize it by so-called flywheel. Flywheel, when press is working, it permanently rotates. Engine rotates this flywheel, and time to time it switches the gear. And no, what does it mean time to time? It has so-called pedal. Right now, this pedal, you might see it. No idea what is the reason to place it there. It's pedal for foot, actually, of employee. And this pedal is on the table right now. It's of orange color. You see, oh, sorry, you see it. And what I did wrong. Immovable stationary table and movable element rem. Rem start motion when someone clicks the pedal. No, and in order rem to start motion, here you see two buttons. These buttons for blocking. If even you click the pedal but you do not touch both of these buttons, this press doesn't work. It's to prevent. It's quite typical technical term. It's not to deceive someone, not to offend someone. It's called foolproofness. Foolproofness, or to protect of silly people from silly people, to protect the silly people from themselves, actually. In order someone by mistake do not squeeze fingers or nose or some another protruding elements of their features of their body inside of die, inside of working machine. No, whatsoever how many different ways we are trying to prevent it, someone will find the way how to do it. Так, next, it's called foolproofness. Once again, it's technical term. It's a normal term. Do not be confused with this. So equipment is press. Here we see mechanical press. Time to time, also hydraulic presses are used for specific types of operations. So for instance, for deep drawing, preferable are hydraulic presses. And when it comes about stretching, also for stretching, presses are of hydraulic type, not of mechanical type. What is the difference? No, for those who operate them, above all, the primary difference in the speed of work. Mechanical press is much faster. It's apply force. It's external speed. It's not speed of deformation. It's speed of deforming force application, let's say. What this external force velocity, external speed is in the range 12-15 meters per second. Such press is able to, the slow of them, able to make 40 strokes for the minute, up to 150 and more strokes for the minute. Practically, they are shooting like gun machine. In case it's not a man who working with the press, in case we use some automaton, let's talk about this, not right now. And hydraulic press is more slow. And hydraulic press typically work with the speed 3-5 meters per second. It's obviously more slow. When you watch this work, you see it's slow in contrary to their no, in comparison at least to mechanical one. So how to recognize? You see here, you see flywheels, and when it comes about hydraulic press, you will see hydraulic cylinder, at least one. Either rim joined with hydraulic cylinder to the basement of machine at all, or even some hydraulic cylinders will be available and you will see them. And on this table, on the table of on the table of press, you see there are two flat plates. They are not able to deformate anything at all. They are able only to squeeze something. In order to change shapes by using this machine, by means of this machine, it's only applies the force. We need to place here tool, and this tool will be tricky hidden actually inside of tooling. Right now we will see something else. Not the thing what I mean to show you. What you see right now, it's no, here is cutting boss and deforming die. You see right now combined die. In the same working position, it's do first cutting and next deep drawing. And cap-like type cap-like part is removed from the die. Altogether, it's called die. What is an instrument in die? Immediately here we see it's called punch and die block. Oh, in such a die, maybe it's a little bit more complicated to understand what is what for those who begin only their studying. Problem is it's combined die, and here we have punch. No, what when cap is what this one, and now it's placed onto punch. Punch is this gray thing at the bottom. What you see gray at the top, it's die block for punching punch, for piercing punch. And at the same time, no, for drawing punch in this case. And at the same time, it's punch for outer cutting. And die block was just die block. Here is this olive part at the bottom. No, that die is impressive, pleasant to watch, but little bit complicated to understand. Once again, we have punch and die block. Punch and die block are one tool practically. They can't work, no, seems like at least they can't work one without another. What we may compare it with scissors, for instance. In case you have scissors which consist of one blade, it doesn't cut. No, you may use it as a knife, of course, in case of scissor. But punch and die block together, it's one tool. But this one tool consists of two pieces, which in space they do not coincide. And in order to align them, in order to direct them, and more probably automatically, without intrusion of employee, without thinking, without measuring, without anything, you surround all these punches and die blocks. It's maybe some in one die, it's maybe some such couples, even in one little die, it may be some punches and one die block, for instance. When it comes about big dies, when some working stations combine it in the same press, it will be maybe some tens of punches and die blocks. All of them surrounded with guiding parts, plates, guiding columns, so on. Punch holders, doesn't matter right now. Story is that all this tooling is necessary to direct two halves of the tool, punch and die block, with respect to each other. And one more group of elements in this die, it's necessary to direct the strip with respect to the tool. Strip, you see it's of red color. On the back side, at least you see a couple of pins there, but besides of pins, it's maybe some additional devices that are necessary to direct them one to another. Okay, I hope that one we understood, this basic point that we have equipment in the view of press, tool, die, and inside of die block and punch, and all these things, they are surrounded, let's say, with design of punch in order to direct them one into another, and in order to direct the metal with respect to the halves of this tool. Так, let's continue. And let's talk about types of operations. Now, what is important thing to remind you also? I hope you do remember what did I say at the beginning already, maybe sometimes. Manufacturer has, no, let's say, open purpose, open aim, and this open one, it's to produce product of certain quality according to technical specification in necessary amount and in predetermined terms. So, no, you oblige to your customer to supply some amount in some terms, and it's called program. So we have demands to quality and we have program. And seems like our point is to comply according to comply this program, to work according to this demands of customer. Yes, but we also have secret aims, secret goals, and these secret goals are, do recollect, please, a second or two for you to recollect, and I say correct answer. We are much interested to save both money and time for manufacturing. Whatever expenses for manufacturing, we are interested to save. Actually, we are going to sell the product by the same price to the customer. But the more we are saving in manufacturing, the more profit lasts to us. I hope you understand it very well. And besides of like obvious direction of any technological development to satisfy demands of customer in terms of quality of product, according its correspondence to technical documentation, to technical specification, to satisfy customer with appropriate quality, amount, and be on time. We also try to construct our technological system in manufacturing in such a way that it's operate with saving, with reducing amount of whatever resources, material, time, money, labor, in order these resources we might use for yourself or for achieving another profit, for another manufacturing, for development of our manufacturing. Or maybe you say, we save this time and spend it to our leisure, to our personal life, whatsoever. So when we study processes, do pay attention also what is what tricks, let's say, are used in order to to follow to the second secret aim, in order to save time, money, and labor force. Very well. To start with processes, and the movies that may help us to understand something, to see something, we will see later, not right now. And moreover, you know that if I have some movie, I'm trying to send it to your chat, to DingTalk. And seems like we are going to start with drawing, deep drawing. What is deep drawing? Do pay attention. Oh, here is. Da. Do pay attention to the picture. What we see on the left, we see workpiece before process, and after process we have this drawn part. And it's called in literature, in books that you may find it in this book, for instance, of Michael Groover, that process of producing of hollow type part, cap type, box type, so on. The parts with inner hollow, with inner cavity. You see here is cylindrical part, but also it's may be of different shapes, including rectangular, not compulsory axisymmetrical parts maybe. And once again, to pay attention to what do we see here in the picture in terms of tool. We see only in a process, in progress. What do we see? We see only the block and punch, and blue plate we see it's a clamp which necessary to hold workpieces during process of deep drawing. No, it also has some additional functions to improve process in some term, but that we are not study right now. First, green one, it's dia block. Dia block looks like plate with the hole of appropriate shape, the same shape you have in a punch. And if you remember the pictures that we have seen here, maybe you recognize that whatever it's called here, practically it comes about deep drawing, because scheme is the same, a bit different shape only. And here is. Da. And what should be said? Why it's drawing? Why it's how to distinguish drawing, forming, or bending, for instance, or stretching? No, maybe it's difficult to understand from the first time, but look, I hope you do remember what I explained about this inner structure of material, inner structure of metal, and you do remember that deformation is resulted in changing of structure. And moreover, the structure may be even spoiled in process of deformation. In case deformation are higher than so-called ultimate deformation, part is broken during technological process. It just crack and that's it. And while drawing, there is the piece which is not changeable at all, something like non-spoiled ever element. Here is the bottom that is under the punch. Now, typically, this bottom is without hole. It's maybe with some little hole, but typically it's without hole. If necessary to make some hole here, typically it's made after the drawing operation. And this bottom is the only element that is not spoiled. All other elements of this part, what all this territory, however big is it, it will be squeezed through the die, jam it, chew it, change it in order from flat one. Do you imagine this flat outskirt will be after a cylinder? Of course, it passes through the hard deformation. By the word, typically, where so-called dangerous cross-section, where it may be teared off at this place, because at the place near the bottom of punch. If it's cracked or tear it off, it's happened in this place. And once again, deep drawing, what it's necessary for? To produce hollow-like parts. I hope it's clear. And in this process, practically all material besides of the bottom, it's subjected to the severe deformation in process of deep drawing. Very well. Now there are nomenclature, so-called, of the tool and tooling used. Now let's recollect that one: dia block, green one, punch, gray one, they are tool. And this one, blank holder, it's called here. It's a clamp, it's a holder, however it's called in different literature. And this one, it's already element of the tooling. And all these things, they actually will be hidden in a die, in some structure. No, not quite. Oi, oi, oi. It's not friendly to me, you see. It doesn't show me this GIF. Why? Ah, because this GIF maybe was somewhere else. No idea why. All the elements like punches and die block, they will be somehow arranged and inbuilt in such a structure which is called die. Very well. Let's continue. Ha. Let's continue. It show whatever. Maybe it show GIFs separately and pictures separately. Так. Next. What is next? It will be, what really it will be like jumping over the processes. That one is considered the deep drawing, and result is the cap-like or box-like type. Next process is bending. Now, what just to make you interested, to make you less bored, you see right now bending die. It's one of hundreds of variants of bending, actually. The very first, what we see. Get lost, please. Why? No idea why. The very first thing we may pay attention, it was flat workpiece. After it passed bending, it has some angles, some corners has appeared along the line. Corners has appeared. There are no any hollow like part, no any caps, no any box. Really, bending is working along some line, typically along straight line, but in some cases it may be also curvature. Typically, but not completely like this. We will see it right now that it's considered that there are 4 schemes of bending. No, that is funny die with rotary elements. You see, it's work simultaneously in some places, and a punch is at the top, and these rotary elements altogether, they are die block. And we see also pusher, we see some holding elements to hold these elements of die block. Directing elements will be for the punch and so on. They are all inside altogether of die block and punch inside of die. Die is a tooling, punch and die block, they are an instrument tool. What is important to understand about bending and how these different techniques of bending at all they appeared? No, even since childhood, you already have familiar with such phenomena, which is called no, it's called in English. It's called spring back. Let me to show you. Here is the. However, it's called in Chinese. Of course, you're supposed to understand. I hope you already recognize it. Spring back effect. It means that after the bending, portion of being bent, no, due to the same effect that we've been talking already when we talked about the structural spar, for instance, да? Where it was tensed, where it was extended, some layers are extended and some layers are compressed inside of the same material. Where it was extended, it's trying to shorten it again, and where it was compressed, it's tried to elongate, to extend it to the normal state. And due to this, some residual energy, not residual stresses, residual energy. Some residual energy is some elastic energy, so-called, that is stored inside of material. It's trying to spring some piece of material back. And this spring back effect, it's the Sorry, it depends on the radii above the all. It depends on thickness, of course, of material, and depends on radii. How it's made depends on radii. Pay attention. No, I'll place here on purpose right now. This picture was red color, and this picture where it's shown radii. Do you imagine that it's little radii here? It means that very little zone is affected by this deformation, by this tension and compression effect. Little zone, little volume of material, little energy is saved inside of this little volume of material. But if big zone is affected with the same tensions and compressions, uh, their stresses in elementary volume are the same, but we have much more those elementary volumes, and spring back effect will be greater in this case. So the more radii, the more significant bending with little radii, it has less spring back effect. But if you're trying to bend something a little bit with big radii, spring back effect is significant, and moreover it's very notable on this big radii, because really you're trying to change the shape not much, and this not much it's even spoiled significantly after. And some ways, some technical means during bending, they are directed exactly to release, to compensate the spring back effect above the all. So bending on one hand, it comes about creating the angles between portions of the look at this, making the angle between elements of parts, or elements of parts or semi-finished product workpiece. Bending is making the angles inside the part. I hope you will remember this. And with any actually process, we might have those spring back effects, stretching, forming, bending, deep drawing material pass to significant plastic deformation and the whole volume of it. So usually it's already no problem with spring back effect. It has a lot of another problems during deep drawing and after deep drawing. So spring back effect is the least problem. And when bending, spring back effect is so-called headache. Do pay attention to these pictures. These pictures, they are so-called schemes of bending. No, there is not visible where the angle has appeared. And final one, fourth one, it's already at all without angles. So seems like it does not correspond to the definition, but no, all of them, they are directed, whether it's whip bending, whether it's dia bending or free bending, they are directed for creating angles. And to pay attention each time you meet dia block, second one, and punch, dia block and punch in each picture, besides of rolling. Once again, we meet this name, rolling. It's already for third time. I hope you do remember. So rolling, it was in primary deformation. Rolling, it was one of operation of open dia forging. And again, rolling or roll bending, it's also maybe called. But in some books, you may find it just with name rolling. Don't be confused. Watch the context each time, what it's about. And all these schemes, they, once again, remind you, they demand both punch and dia block. And you understand, punch and dia block, they are made of metal. No, let's see on the drawing, for instance. If you change or don't look at this picture. Do imagine that you need some another diameter. What does it mean? You need another couple of punch and dia block. If diameter differ even for 1/10 of millimeter, it's already a problem. Or you have punch and dia block, which, no, it's quite clear. They have clearance here, which correspond to the thickness of material. What if you need to work with another thickness of material? Again, you need another couple of tool. No, at least half of tool you already need to change. That is a significant problem. It's not universal instrument in deep drawing. In bending, is it possible to use universal instrument, universal tool to save money? Once again, remember our secret aim. We need to save money for ourselves. And in some cases, it's possible to reduce costs for manufacturing by using, as I said, you already, some technological tricks. And that is why some schemes of bending has appeared, including this rolling one. Let's see. For instance, that one, you see, it's die bending, so-called, which correspond to the second picture here. No, it's maybe called air bending, bottoming. No, in another literature, it's called dia bending because it's inside the dia. Or it's maybe called V-block bending also. You might see the name V-block or V-bending, and you may understand what it comes about. Dia block here is at the bottom and punch at the top. And seems like it's create one angle along the line. Why it's called air bending here and bottoming here? Because do pay attention. On the left there is the gap clearance. They like they have not passed to the end. It seems like. In contrary to the right one, when they already touch at the bottom, and that's why it's called bottoming. Don't be confused with dozens of names. I'm already said you in English they have significant problem with terminology. As I get used to see how it's given in our textbooks, and we have terminological standards, how we should call that or another process. In contrary to this, of course, Western countries, they may use different names. You see, along one line, it's create one angle. Now let's see here. It's the same process. It's a process of V-bending, but this process already resulted in creating of parts of complex shape. No, of course, punch a little bit different, we might see, but dia block, it's the same. It's just plate with V cut. If we'd like to have straight angle, V cut is of 90 degree. If we need something else, it will have another degree. Moreover, I should say you that these machines, V-bending machine or V-brakes, they are also called. It's just mechanical press, but with very long table, narrow and long table, in contrary to what we have seen in the picture of mechanical press. Disappeared. Oh, that one, it has a rectangular or even square table. Typically, the V-brake or V-bending machine, it's the same press, but do imagine table is narrow and with the length some meter. Let me to show you in another picture those V-brakes. What there is a photo of real one, but no, of course we not see the whole length. Or approximately like this, like such machines looks, and you see a punch fixed at the top, very long. You may do very long workpiece, work with long workpiece simultaneously, and dia block at the bottom. But the same machine also may be used for short parts, like it was in a photo here. And how machine itself work? It's so-called universal machine, which realize this type of bending. Actually, you may use this V-bending in a simple mechanical press. You may create your own dia, like it was, and use simple mechanical press. But also there are so-called universal V-bending machine. It has dia block and punch, and it has so-called back gauge stopper, which is responsible to stop this yellow one, its material, responsible to stop the workpiece in proper place in order to provide this angle in proper distance with the edge of the part. And in this GIF, it's visible how it's work. No, you see. In case this machine is of old type, it's necessary to move by hands, let's say, either by measuring or using templates. No, manually, this stopper is replaced. In case it's a CNC machine of new generation, no, a new generation, it's last 20 years. For you, of course, it's not you. Not new, as far as I understand. What this new generation of machines, it's usually a CNC controlled stopper, and it's necessary only to follow no, to follow the program in terms that rotate parts with necessary sides. Maybe you need these flanges from different sides of part, and in this case, you just need to rotate the part, staying not far from machine. And it was, once again, it was this scheme, V-bending. What is called air bending or free bending, it's very similar, actually, and even maybe realize it in the same machine, especially when it's CNC controlled. It's just like non-finished way. On the way, it's not finished. In this case, part fuse apart. It does not repeat the shape of the die, and moreover, seems like in the same die, maybe we may do parts of different radii depending on the shape of the punch. It's already somehow reducing the spans, the expenses for tool. In this way, it's possible to save money somehow. No, not ideal way, but already give opportunity to save money. Third picture, this one, it's so-called whip bending. Or whip bending, it's great thing at all. It has no punch. It has no, supposed to be some forcing, deforming force applied, but the thing that apply this force, it's not a tool. It's in terms that it's not the same shape. It's maybe use completely universal thing, whatever die block you need in this case, and it should have at least the same angle and the same radii as fuse part. You have clamp here, this one, what number 3, it's a clamp, but you have no punch at all, and it save money. Here is what with bending. No, it's called punch here, but do forgive me, punch. Yes, you may call it punch, but for different die blocks, for different radii, you may use the same punch. It's already saving the money, and it's called whip bending in English. Once again, and I said that I will remind you about the spring back effect, but now reminding you about spring back effect. If it's spring, it's moving back, but we need it in such a way. We need it with some 90 degree, but after bending, it seems like it will be not 90 degree, but let it be 95. How to make it 90 after bending? Now, if you know by your previous experience, by statistical data and scientific article, you understand that for this thickness, for this radii, it's spring for 5 degree. What is the obvious decision how to improve your tooling in such a way that you have 90 degree after bending, understanding that compulsory it's moved back to 5 degree. After a second of pause, of course, you're right. Instead of tool with 90 degree, you do tool with 85, and after bending it spring back to 5, and you have altogether 90. It's one of the possible way to do it, but not the last. You may change shape the tool, and due to this, you have seems like solved problem of spring back effect. No, at least compensated, not solved, but compensated. It's one of the way. Let's remember this. In another place, we will meet another decision. Roll bending. That one. It's great thing at all. But it's usable only for specific elements. No, specific parts. What do I mean specific parts? It may be used only for creating of cylinders and cones. How it's work? No, in contrast to simple rolling where it was thinning and thinning, reducing in thickness between two rolls, it's very similar. It looks like roll mill, but it has three or four or no, typically three rolls machine, but maybe even four uh, rolls, long one, which are placed in some distance with respect to each other, not just distance of thickness of material, a little bit far. And by changing the position of axes, if you place, for instance, this roll number 4, if you place it higher, it will be greater RD. If you place it closer to the bottom one, supporting one, it will be less RD. It will be more cylindrical one. No, and by changing angle between these rolls, you may create cones. So great thing, but it's work only for cylinders and for cones. And of course, it has some strange back effect after. This strange back effect, it's spring back effect. It's solved by, no, in this case, it's solved by rolling front back for some times. No, in order to make more significant plastic deformation in the workpiece, and in this case, it's correspond to the finally necessary shape. Well, here we see again one variant of V-bending machine, and here we see reminding what did I said. It's not compulsory to use this V-bending machine, especially when we're working with little parts. In case of using the simple die, simple or something tricky one, I place it here on purpose, those pictures with interesting dies. Because typical one, it will just a plate with V-like cut, maybe. Yes, immovable. But that one is more pleasant to watch. And of course, that one is more universal. No, maybe it's not obvious for you right now, but in this case, if you change punch with another angle, with another radii feeling of the edge of the punch, you may use the same rotatable elements, but another punch, and you will have another shape of the part due to this. And once again, punch, rotatable elements are die block, and all other elements, they are die and they are tooling, which help to direct elements to what those pins on the die block that you see, they are necessary to align workpiece, for instance, inside of the die before you start work. That one you may place to usual mechanical press and work with this. It has, what this one with rotatable elements, it has some variants of universalization of it, let's say, but it's not universal. You understand? No, I hope you understand. And the bending machine, it's much more universal thing, and moreover, typically in their supply set, let's say, they already have some punches and some die blocks. Moreover, normally one die block, let me to show you in real photo, not here. No, here it's visible, but not much at the bottom. One bar, rectangular long bar of die block, it has cuts from 4 sides, at least 4 different cuts it has. So the same piece of metal, it's used like 4 different die blocks. It's quite typical decision. And those V-brake machines, what they are good so good with, what they are loved with, loved for by manufacturers, because they are universal with the same machine. only changing these universal tools, no, maybe not even changing much, you may produce great variety of different parts. In contrary to simple die, if you have some die, this die is able to produce only the parts it's designed for. But if you need to produce thousands of parts during some years, quickly, reliably, interchangeably, die is a good decision. Quite clear that designing of die, manufacturing of die, maintenance of die, all this cost additional money. And if you need 5 parts, for instance, or 10 parts, no way to produce the die. Design it some months, next wait until it's manufactured, and so on. No way. And if you need 5, 10, 20 parts, you just check whether punch in the block machine it's already adjusting to your part, or you need to select another universal one of the same punch or of the same block machine. And next you can already start work in a couple of hours, for instance, with universal equipment and universal tooling. That is the idea of this machine. No, that is only to show you how it's possible also. Rotatable elements, die with rotatable elements, and it's create bending. You see, it's creates the pipe due to the rotation of these elements. Well, now, now actually I already said it. Roll bending. Да? Here we see what it looks like in space. This one with supportive force set of rollers. Either it's create cylindrical shape or it's create conical shape. Very simple machine, universal in terms that by changing of distance between rolls and by changing the deviation of those rolls with respect to each other, angles of them, you may have different radii, you may have either cylinder or cone. Seems like great thing. In terms of universality, it's great thing. The same shapes you may produce by another way. Yes. No, like it was here, for instance. Something like here. It's also creates cylindrical shape. But once again, that one is a die which you need to design, you need to pay for its manufacturing, and only after you will use it in some months, and you already spent additional money, which included in the cost of each part. You understand it? That one is cheaper, but as I already said you, with some limitations. No, here is the video of real one that was sleep it right now, and the same process may be used. Here we see a process for sheet. The same process, roll bending, it may be used for pipes, very popular one, and it may be used for profiles. That one is even complicated machine here is represented. When it comes about bending, rolling, we already not calling something like punch and die block. Like it's difficult to distinguish who is who, punch and die block. And if something no, in case of to find whether punch and die block, what is is punch, what is die block. Punch is intruding part with which intrudes inside the workpiece, and die block it's usually do not understand how to say it in English correctly. No, what else? What another names you may meet for punch and die block? Do forgive me, don't mean to confuse someone. It's official English terminology. Punch it's called male part or male die, and die block it's called female die or female part. Like this. So you understand, one is like receiving with the hole it's a die block, and another is intruding, it's punch. And once again, rolling, it's also rolling, but it's already roll forming, not even roll bending, roll forming. Look how interesting process is. Very popular. By the word, it's very popular in aircraft manufacturing, at least in our countries of former Soviet Union, for making stringers from sheet. Look, the flat sheet or flat strip of the sheet pass through some pairs of rollers, and rollers are created in such a way that no, step by step, continuously, of course, but it's step by step changing the cross section of the sheet of the strip with minimum possible stresses in order not to break it, not to tear off something on the way, not to create a maximum of deformation, this ultimate deformations inside. It's changed from flat shape to the any shape you need at the end. No, not quite any, of course, there are limitations also, but to the shape which completely different from flat shape, and its length, no, the length of this part, it will be as long as length of the strip you roll through all these pairs of rollers. Very simple process, very quick process, very convenient process. In contrary to the bending machine, which, oh, yes, no, let's compare here what scheme of a bending machine. The bending machine may work only along one line, this V bending. It may work with no, more primitive shapes, let's say, and more probably it's not create you such a shape with some half cylinder elements and so on, or at least it will be significant spring back effect here. When it passing through this some pairs of rollers, it's proven that spring back effect may be practically absent because it's passed through the some subsequent plastic deformations actually. Well, no, the same. Just to demonstrate you what it looks like. You see couples of rollers demonstrated in cross section. Let's come back. And here is the movie that we might see later. Next, I hope we might find here is written should be where the next one. No, I'm not see it. Okay, let's use slides then. What is next? Wow. I forgot to say at the beginning. That sheet metal stamping, it's practically around 25-30% of all the work, of all labor input, let's say, of manufacturing of parts in aircraft manufacturing. Typical structure of airplane inside. No, that is of course for so-called light airplane. What we have seen in slides, you do remember, I hope, what is typical appearance of the fuselage inside. That one, outer side, cylindrical fuselage, you already understand it may be produced by roll bending, for instance. Stringers, no, depending what they are made of, profiles or sheet. If they are made of profile, they already of this fixed cross section, and it's necessary only to cut the necessary length of the piece. If it's made of the sheet, because more delicate structure is, in this case, what we may use, in this case we may use either this rolling, sheet rolling, or we may use the bending machine to create stringers like this. And finally, it will create us something, some shape that we need actually. Here is, and this something typically it's of Z shape. It's maybe L shape, maybe Z shape, typically Z shape. for stringers when it comes about aircraft manufacturing. And one more interesting element, airfoils, which supposed to be ribs. Да? In order to hold this shape, airfoil-like shape, we have elements like ribs inside the airplane. No, actually frames we also have, but frames are more simple in the shape. And the process of creating of these ribs. Do imagine the wing. I remind you what it looks like. What even simple one. Simple airplane, how many ribs it has? And it's straight wing. It means that all the ribs may be of the same size and may be produced by the same couple of punch and die block. Do remember this, да? That if we need to produce something by sheet metal stamping, this something demand punch, die block. Any changing in size, design, shape, another couple, punch, die block, another spending of money. Вот. And if it was little airplane, do you imagine how it's difficult, how many in nomenclature, different ribs and pieces of ribs, because we have nose rib before the spar, next we have central rib, and next we have either tail of the rib or separately. Spar is go through and rib may be divided onto 3 portions, onto 5 portions, depending how much spar you have. And in case you have here either flight control or high lift device, it will be already not tail rib, it will be some some more little ribs inside of this flight control. Dreadful amount in nomenclature of these ribs. Wing, half wing from one side, half wing from another side, stabilizer, fin, flap, ailerons, nightmare, technological nightmare, because for each couple, for each of them, you need couple of punch and die block. In the best case, when we are lucky, left and right one, at least you may produce by the same couple, but not always. And of course, watching all this, we're already about to cry and think how to save money, how to save money. If it's not possible to save our time and time for preparation, for preparing of all these tools, at least maybe it's possible to save money somehow. No, for punch, for instance, or for die block. And people has decided to use, it's called two next processes that I will try to explain you. They are called forming and stretch forming. In both of processes, half of tool is absent. You will have only, no, you may call it die block, consider it die block or punch. Actually, they are punches. No, by this terminology, with this male part, female part, they are punches because they are intruding in the part inside of the workpiece. But they may have different names. But in particular, that one which used for forming or flanging, another name of this type of forming, it's called form block. No, because really it's like a block, piece of plate, of course, of specific shape, and it's maybe called form block, it's maybe called forming punch, and okay, but how to make material to take the same shape as the sponge? And in this case, we will use, do not remember whether it's shown here in my notes. It's not shown. Oh, great. Wow. This funny creature is assembly jig for spa, for frame. Okay, will not try to search it here. I will show you in slides, and in slides, what forming the bending once again we see forming maybe of complex shape like this. It's not drawing because it's not closed shape, it's not closed in perimeter, and it has no squeezing of material through the gap, let's say, between punch and die block. It's only changing of the some layers of material, and more probably, by the word, the most of these parts, ribs, some diaphragms, elements, they actually do not affect deformation, do not affect the whole area of part practically. It's affect only on some edges, outer edges, inner edges, typically like this, or some local deformations, like you see here in our language, it's called Puklevka, and in English, do forgive me, not difficult to say how to call it, because they might use different names for those bosses, embedding, and so on. And in picture that we now, this one, this long and narrow local deformations, this one is typically called rifle. What that is in English, it's stable name, stable terminology for this. And in order to make material take the same shape, how it's work? It will be, sorry, what here is form block made of wood, and even already, no, that is for manual work. It's already clumped the piece of material, piece of sheet behind of it to this form block. It will be combined with block of resin of polyurethane. It will some container with polyurethane, and this container placed not by press or not manually, quite clear. It's placed to form block with this workpiece already clamped to it, and polyurethane compress inside, and because it's it's like unboxed in this container, it does not try to deformate somewhere outside. It's locked inside of container, and it creates this compressive stresses inside of polyurethane. Polyurethane has no exit to sides, and polyurethane make this material, this metal sheet, to form, to change shape, and to form according to the shape of form block. The interesting truth is that it's even possible to cut by such a way, not only to deform, but to cut. No, for cutting, quite clear, this form block, it should have not radii, but sharp corner at the place where we're going to cut. No, and some additional conditions should be preserved, let's say. Will not explain it right now. Just do remember it, like in head. Do remember this, that for forming, flanging, it's possible to release one of tool, no, half of tool. It's possible to work only with the punch without die block. Instead of die block, it will be universal block with polyurethane, place it in container, and due to this you save money. Of course, quite clear that metal die block is more reliable, it may stand longer work, but if you don't need some hundreds of the same part, never ever, maybe you need to produce 50 such parts, and that is all your program. Why you should spend money for metal die block, which is able to stand 2000? It's expensive, able to stand 2000 that you don't need. You need only 15. And in this case, of course, this stamping by rubber, it's called, it's a great thing at all. Truth is that not everything in deep drawing is available for this process, but some geometries, let's say, of deep drawing, they also may use this process. Such tricks like using the polyurethane, using elastic parts instead of metal one in tool, I mean. And what is interesting that instead of block of polyurethane, people has developed machines. It's called hydroforming. Do forgive me, I have not prepared its beforehand. It's still Igor Ivanovich Sikorsky here. Hydroforming. It's, if I'm not mistaken, it's even show us the process animation. Yes, hydroforming. Look, machine, you see. No, it's not quite like it's shown in this resource, of course, but rather similar. Here is we have, no, in this case it's dia block because you see, no, with cavities. It's maybe considered like dia block. No, however you call it, doesn't matter. It's covered with the sheet material, and next here is, it's something like rubber container, but it's rubber container filled at this place, what is not shown in this GIF. Rubber container filled with liquid, and when machine is closed, container filled with liquid under pressure, and this change the shape of material. Great thing also to save money in terms of universality of no, flexibility of the process. It's a great thing, and this pressing by or forming by rubber is or hydroforming, it's maybe called. It's extremely popular process in aircraft manufacturing. Why? Because typically we do not work by thousands of parts. We're working with hundreds or even tens of parts. And next, object of manufacturing is changing, because normally no one produces the same airplanes but by thousands, by tens, maximum by hundreds. Very popular company, but not by thousands. By thousands, airplanes been produced only some types of airplanes during Second World War, when it was need in big amount of fighters. And why it was so great need in fighters and bombers? No, bombers it's more longer in its life. Fighter typically 3-4 flights and goodbye, it's destroyed. And because of this, it was great manufacturing of fighters, really by thousands, even by millions. I was said about one of our Soviet fighters, Lavachkin. But in normal life, no one need thousands of the same airplanes, and object of manufacturing is oftenly changed. And one more great way I will show you to save money, it's called stretch forming. Stretch forming, and in case it comes about bending, it will be called stretch bending. There is only difference in name: stretch forming for sheet, stretch bending for profile, but principle is the same. What is this stretch forming is about? You do remember I said about spring back effect. In order, no, do imagine that you combine deformation of where it was picture of spring back. Here is, да? Do imagine how spring back is appeared, because we have tension layers and compressed layers, and because of this they are trying to rotate part in normal position, no, in previous position, to reduce the angle, no, in contrary, to increase the angle, да? What if we have no these compression layers? What if we have only tension layers? What tension layer try to do? It try to shorten, extended layers trying to shorten, and compression layers they are trying to extend in contrary, and due to this it's appearing so-called moment, spring back moment. But what if all the forces act in the same direction, but they just act with, no, let's say tension on the outer layer will be greater, tension in the inner layer will be less, but it will be still the same tension. What may happen in this case after you remove force that deform the part? It will not be spring back effect. It will be shortening the part, but not spring back effect. And for huge sizes of parts of complex shape and of higher radii, of no, great radii, they are practically flat. For instance, like panels of wings or some complex panels of the nose fuselage, aft fuselage, fin stabilizer, something like this. For them, their sizes are great and their shapes are practically flat, barely deformed. In this case, this spring back effect will be too much unpleasant. And parts are great in size. What does it mean for us? Great in size part, it means huge punch, huge dia block, and huge equipment to operate with. Not even much force is necessary, but table of equipment must be huge. No, we don't like it. We'd like to save money. How to do it? And stretch forming should help. Stretch forming will use only punch and clamps on sides. Truth is, there are three variants actually of stretch forming, and it's maybe with significant stretching, it's maybe practically without stretching, and it's maybe so-called circular or ring stretching. No, that is not the matter right now. What is interesting for us is to see what it looks like. Look, here is stretching machine. What there are stretched parts. You see the size. No, I hope it's understandable for you what are sizes of these parts. They are really huge. Punches for them. Punches may be made of wood, may be made of metal, maybe wood made of concrete even. But typically there is the only part in tool, punch. And when in hydroforming or pressing by no this stamping by rubber, it was necessary at least universal another part like counterpart, now the punch and block with block of polyurethane, the punch and container with liquid. In this case, no need at all, because this no, take a look by the word. Do pay attention to the size of the part. Here is a man, you see, and these fingers, these robotic fingers, clamps, which hold the part and they will stretch it. And pay attention. Here is those fingers are somewhere on behind. Well, no any punch at all, but what, oh, sorry, no any dia block at all, no any universal even block at the top. But what will be? Punch will move. In this case, punch will move top. Punch is placed on the table of machine. It's very specific machine. It's called stretch forming machine. They may be, as I said, you of three different types, but practically it's hydraulic press. What you see, hydro cylinders which work with, operate with these fingers, clamps. Just in some types of machines, these clamps just stay on the place and hold the part. In some types of machine, they will additionally stretch it, preliminary stretch it, and next punch move top. And punch move top slowly. Also, it has its own hydraulic cylinder. And due to this, part will take the shape, receive the shape of the punch. Now, through all that, it's necessary to spend a lot of material for additional, uh, it's called allowance, additional material for clamping. Truth also that not all this part it's finally usable as a part, and a piece of sheet that we place to such a punch to such machine, it's much greater than part that next finally will be cut from this place. But no spring back effect, we saved much money for tooling because only half of tooling is necessary in this process. And in this case, it's considered, usually it's of course used for big parts, not for little one. If for little one it will be too much because you will spend sometimes more material area for clumping in these clumps, in these fingers, robotic fingers. But you understand that in this case, for big parts, for huge sizes, and without spring back and of specific shape, where we have no their no, where radii curvature is very low, radii great, very big radii, curvature is very low. And for these complex shapes, it's maybe the best choice at all. It's called stretching once again, or stretch forming. But also forming is available, as I already said you, with normal couple punch die or with using the rubber. And rubber in this case, rubber or polyurethane in this case is, what is it? Equipment, tool, tooling, of course, tool. You are right, it's an instrument. Rubber work as an instrument. Well, time is practically over. There are not all operations of sheet metal deformation operation, but the most popular, let's say, once again, deep drawing, making the cup-like type, hollow-like type, flat sheet, and created the something like cap or barrel. Bending, it comes normally it comes about making the angles between pieces of part, between elements of part. Forming, flanging, stretch forming, and different schemes of these operations, and at all like development of this operation, how it's appeared. No, due to the fact that we have secret point, we'd like to save money, time, labor source, labor forces, and so on, whatsoever, while manufacturing, to our profit. Yes, to use this money, time, and labor force for ourselves above the all. But we provide, of course, quality as it was agreed with customer according to the contracts, so on. Quality program, everything is fulfilled, but of course, as much as possible, we need to save resources during manufacturing, thinking about ourselves. And one more unpleasant moment when we're working with the sheet metal, that while deformation of the sheet metal, in some cases we deal with a spring back effect. In some cases, the spring back effect practically absent just because part pass through extremely severe deformation, plastic deformation. It's already forget about any elastic energy. In comparing to this plastic deformation, this spring back effect practically is absent. More probably we tear off the part, but certainly it's not springing back. But for bending operation, and especially when it comes about the forming the huge surface, like what this stretch forming, for instance, of course, spring back effect is significant and extremely unpleasant. And when it's simple shape, like you just make in the corner, it's possible to save problem by preliminary increasing the angle of bending. If it's necessary to bend straight angle, you bend it more. And after it's spring back to some value that you preliminary more bended already. But when it comes about complex surfaces, when it comes about huge sizes, it doesn't work, this approach. And because of this appeared another ways of bending or another ways of forming. And plus additionally that we are striving to save money for tool. And as we have a lot, very wide nomenclature, a lot of parts of different shapes and sizes, and for each of them seems like it's necessary to have couple of tools each time. Once again, if it comes about thousands of parts, of course, better to produce metal punch and metal die block, no problem. When you need to produce some thousands of parts of the same shape, of the same size. But when it comes about tens or maximum hundreds, it's not feasible. And in this case, we using either rubber as an instrument, or we don't use some stretching machines or some another schemes of deformation, no, not deformation, deforming schemes of deforming in order to save money and material and labor force, as I'm already said. And of course, wherever it's possible, we are trying to exclude any special tooling or special tools like dies, wherever it's possible, in order to save money both for manufacturing of these dies and time for design of this die and time for manufacturing of this die. Before it goes into operation, it passes through some months in the best case until you may already start using this die. And do imagine that you have hundreds of parts, and for each such a part you need to develop a die. Of course, wherever it's possible, it's better to not use this special specific tooling and tools. Better to use universal machines. And these universal machines are machines for hydroforming, machines for stamping by rubber, and machines, no, like for instance, V-block, V-brakes, да, V-bending machines. In this book of Michael Groover, if you're interested, let's skip the cutting yet. In case you're interested, you might find, I trust, the same explanation, practically the same explanation about different kinds of, as you see, what here is flanging. No, hemming, I not mention it at all. No, it's not typical for us. Flanging, it's very typical operation for aircraft manufacturing. When we have flat part with flanges, there are different schemes of bending, you see, deep drawing. Also, deep drawing, it's not the only picture that you see, it's deep drawing and that's it. Deep drawing has a lot of different variations. And one thing that I have not here is about problems during deep drawing. It's already not a problem of spring back. One thing that I have not explained to you, it's called roll drawing. Here it must be. In some cases, simple deep drawing doesn't work, and instead of drawing like this, deep drawing like this, we use roll drawing. What it looks like, it's somehow similar to turning process. Maybe you understand what I mean, because you are not kindergarten children, do forgive me. And instead of cutter, it's used roller. We have shape that correspond to the inner shape of the fusee part. To this shape, we attach piece of flat sheet, and next shape rotates. This block that will repeat the part next. And a roller slowly but continuously moves from the central point along this shape, and shape is rotates. And in some minutes, even some seconds, depending on material, depending on speeds and technological mode, you will have part which completely correspond to final shape that you need. But in this case, it's not press, punch, dia block. It will be something like punch, but this punch will rotate and it will rotate in machines that very similar to the toning machine, or it's called also leathering machine. Let's stop our record. See you next time.